with us, to pass on the presentation on the pattern for us to with our laptops, telephones, and let's use our microphones and allow the speaker to flow and do the work. So without much ado, I'd like to say, John, I think I'll leave the floor to you to probably continue. Thank you very much.
All right, great. Thank you so much for the invitation, Francis and Samuel. I'm happy to be here. Let me share my screen. All right, Francis or Samuel, please tell me if you can't see it, but I'm assuming everyone can see my slides. So my name is John Blischak. I'm based out of the Midwest of the United States. So very happy to be with you all today. If you have a question, sometimes it can be kind of hard in this full screen view for me to see the chat. So if there's a burning question, Francis or Samuel, you can go ahead and unmute yourself and tell me there's a question. Otherwise, I'll just keep carrying on. Okay, and so I titled this presentation, Tools for Organizing and Sharing Your Research Projects. And I'm gonna talk about two of these R packages I've created for this, Workflowr and OmicNavigator. So first, a little bit about me. So I'm a freelance scientific software developer. You can find out more about what I've worked on my website. I'm the co-organizer of the Cleveland R User Group and the annual one-day Saturday Columbus Conference, part of the larger Saturday.org, which is a worldwide network of R users that create one-day conferences in their local cities. And a quick disclaimer, I'm representing myself today and not any of my former or current clients. Okay, so I'm gonna talk to you about two basic little vignettes. So the first one's about Workflowr, and the next one's all about OmicNavigator. And if I had to find a unifying theme, it's that when you do research, when you can use a cool tool like R, you don't need to email PDFs back and forth or Word documents or anything like that. You can use web technologies with R to more conveniently share and organize your research. So we're gonna start off with Workflowr. So this is an R package framework I created for organizing, versioning, and sharing data analysis projects. It was a big focus on reproducibility. And so why did I create this? A little bit about my background. So my reproducibility journey. So when I was a PhD student at the University of Chicago, I was involved in multiple collaborative projects. So one example is a project where we were doing single cell RNA sequencing. The details aren't that important if you're not a biologist, but the idea is that you need lots of different people. So I was doing more on the informatics. I was collaborating with Po Yan. She was the experimentalist doing the experiments with the cells. And we also had a collaborator, Joyce. She was a biostatistician, bringing in a lot of the more advanced statistical methods. And we needed a way to collaborate with each other. And so we started off just with our code on GitHub. So we could all see our code, but it was also really hard to understand our results. If we showed each other a plot, say in a PowerPoint slide, what data generated that? Because we're constantly generating more data as well. We really needed a way not only to version the code, but also our results. So when we were looking at something, we knew what version of the data, which version of the code created those results. Okay. And also, like I said, a big theme is emailing reports is something I don't like. And so that'll be a theme throughout this, is how to avoid this. So what we would do is we'd have weekly meetings with my former PI, Yoav Gilad, and we would email a report like 5 minutes before. But the problem with that is that it was immediately outdated because we're trying to finish analyses and clean things up to have the latest information at the meeting. So we instantly have to email a new report and last minute updates. It's just not a very efficient way to share information if you're emailing around, say, PDF files or PowerPoint slides. And so like I said, we have so many great tools and we're really spoiled as R users. There's a great ecosystem of cool tools that we can take advantage of. And for a great overview, I really like this review paper by Julie Stewart-Lowndes in 2017. And one thing it does a really nice job of is showing how sort of the payoff for adopting these cool tools is. So on the x-axis, this is sort of a schematic, but on the x-axis is the ease of collaboration. So how easy is it to collaborate with others, including your future self when you return to your own work. And then on the y-axis is the ease of reproducibility. How easy is it when you return to this work to create it. And so you can see as they adopted more tools like R in R Studio, Git and GitHub for version control, and R Markdown, how they were able to get more work done faster. And so what I like about this too is it kind of counters a common narrative is that if I adopt these tools, it's going to take me forever. And if I do things reproducibly, I'm going to be slower, I'm going to do less research. But really, there's only a short-term hit at the beginning. Long-term, when you use these tools that help you become more effective and efficient, you're actually going to do more research over the long run. Because you're not constantly trying to fight reproducibility issues, trying to get your old code to run. And so that brings in Workflowr R. So I'm going to go through and explain how Workflowr R helps you make projects be organized, reproducible, versioned, and shareable. But the end product, so to keep in mind where we're heading, is what it's going to create is a version controlled, reproducible website with your results. And so these are some examples, some screenshots of various Workflowr R users that have used Workflowr R to during the development and sharing of their research projects. Okay, so first, organization. So when you start a new project, it's really easy to just you don't know where it's going to go, so you just start creating files. And then I've definitely done it before. We end up like this XKCD comic where you just have one directory with a whole bunch of files with uninformative names. And that if you ever have to come back to that months later, or you try and give it to somebody else, say a new person in the lab or a new coworker, they're going to have no idea how to get through and find what's actually relevant here. And so their best practices, for example, Noble 2009 is a great paper explaining how to organize projects. And it has directory structures, having your source code one place, your output somewhere else, your data one place. This is great, but this can be a pain if you're just trying to start out a project. Are you really going to have to create all these directories and think this much about it? And so what Workflowr R does is helps you not have to think about it. If you want to start a new project, that provides a single R function, Workflow start, and you can give it the name of your project, that'll become the name of the directory, and it automatically creates all this directory structure for you so that you don't have to think about it. It's just there. And so these are mostly suggestions, but the idea is that your R Markdown files will go in analysis, long-running code scripts will go in code, your data will go in data, docs is where the HTML files will go. And so it's important that this is mostly just suggestions. If you don't like these names, you can change them. If you don't need a folder, you can delete it. The main ones is you need one folder that has your R Markdown files in it and one that has your HTML. And Workflowr R is agnostic to what you actually name these. These are just the first suggestions. Okay, so if you're using Workflowr R, you've already, from the beginning, you have a organized project, which is already going to help you if you return to it months later or even years later. So reproducibility. I was talking about how we're spoiled as R programmers. We have all these great tools. So I really love literate programming. It's really changed. That's probably the biggest thing that's changed since when I first started using R. Is it's so much more convenient for data analysis to have your code, your interpretation, and your plots and tables and output all in one place. This is really, really great. Instead of having to copy paste tables and plots from one document to another and always being worried that it's getting out of date. With this, you always can see the exact code that created a plot. This is, of course, supported by knitr and R Markdown packages. And so Workflowr R is an extension package. So if you're familiar with packages like for example, Bookdown, it's a similar idea where Workflowr R extends R Markdown and knitr. And so the function name is called Workflow Build. What this is going to do is it takes your R Markdown files in the analysis directory, converts them to HTML, and saves them in the docs directory. And this is under the hood is using the support for R Markdown websites. That's essentially what it is. It's a wrapper for that. It's an extension. And the default behavior, it tries to act somewhat like to Makefile. If you're familiar with Makefile, it looks at timestamps. So without having to know any make syntax, it'll automatically look at your R Markdown. If there's any R Markdown files that have been modified more recently than their corresponding HTML files in the docs directory, it will automatically rebuild those. That way, if you have some long running code in some of your documents, those won't get built each time you update the website. Only the things that you changed, only the files that you changed will get rebuilt. All right, and so a big part of Workflowr R is this reproducibility report. So if you read anything about reproducibility, it's usually a long list of various things you need to do. And that can be overwhelming to new users. All these different things, you may not know why they need to do them, or it just becomes information overload. But even for experienced users, if you're working on a deadline, if it's late at night, or if it's the end of the day and you're really tired, or you get interrupted and you forget where you were, it's really easy to make a mistake. And so what these do is try and automate as much as possible all the sort of best practices. For example, setting a seed and various things like that. We'll go through some of them. But the idea is things that can be automated should be automated. You should be, as the user, focusing on your analysis, performing the interesting statistical analyses and creating cool visualizations that help you interpret the data. So a big one that really trips people up with reproducibility, and something you can be using computing for a long time. You can be doing lots of advanced stuff. And if you're self-taught, you might just have never gotten exposed to this. The idea about file paths on your computer, absolute versus relative. So an example here on the left, I have an absolute path that's going to my desktop on a hypothetical Windows machine. The idea is if I use that path in my analysis, not only can no one else use that, run that code without modifying it, I can't even do it if I do somewhere else. If I put it on my on an HPC system where I want to run it there, it'll break. If I get a new computer, it'll break. So it's really not portable, and that really, you want to make your research reproducible. You want people to be able to run it and try it out. This will prevent that. So if you use an absolute path, it will detect it and then immediately tell you what the relative path should be. So if I'm using in my project, instead of giving the full path on my Windows machine, I can say, okay, it's in data/data.csv. That way, if someone puts the project on their computer, it'll just work when the code is run. And feel free, I'll stop for questions at the end of this Workflowr part, but also if there's any questions that people have about any of these particular checks or that sort of thing, or just need a clarification, feel free to throw in the chat or unmute yourself and stop me. All right, so setting the seed. This is something that I was doing R for years before I learned about. If you're doing anything that involves randomness, say a permutation-based p-value or bootstrapping, anything like that, you want the randomness is good. That's how the statistics are working. But once you show that it's working and it's a valid result, if you put it, let's say, in a scientific paper or some sort of report you give to somebody else, you don't want to, every time you change it, having to like change the 5th decimal place because it's slightly different, right? What setcd does is make all the random procedures reproducible. They'll be done exactly the same. So if you have a permutation-based p-value or some sort of bootstrapping-based method, when you set the seed, it'll always give you the same result. So that way, if it does change, it's because something actually changed in your data or your analysis. It's not just because of the randomness changed. And lastly, best practice is to record your session information, but this is really easy to forget. And so what Workflowr does, will automatically run it for you and then put in this nice collapsible button. That way it doesn't sort of detract from your main analysis. If someone's reading your website and they just want to look at the analysis and the results, the plots, they don't have to look at this. But if you are having trouble reproducing your own works or someone else is trying to, they can quickly look at this and see what the version of R was, what the operating system was, the version of all the packages. Say, oh, I'm using a different version of R. Maybe that's the issue, and they can try and troubleshoot that way. All right. Let's see here. Okay, so another thing that really trips people up is that R, by default, it has that option to save your current workspace. So it'll save all the different objects that are defined there. And if you keep doing that, especially if you use it across projects, you keep saving, keep saving, you'll have all these variables just that live in your R session. So that if you change a variable name, or if you haven't defined it yet, code that you run in that session might work only because there was some leftover, variable X or variable Y from, months ago. And that's the only reason it worked. And so what you want to do to make sure your stuff is reproducible, both for you on a new machine or somebody else on their computer, is make sure each time you run analysis, it's in a clean R session. And so that's what Workflow Build does. When you say Workflow Build 2 different files, they don't crosstalk at all. And they don't also crosstalk with your current R session. So if you have libraries loaded in your current session, those aren't used when you run Workflow Build. And make sure that everything in that file is defined. And so we'll go through in turn, build in here, these called f1.rmarkdown, f2.rmarkdown. We'll run each one in turn in its own session. So I already mentioned the variable names. Another thing that'll happen a lot, this happens to me all the time, is you load a library in your session. So you load ggplot2, you're making your plots, everything's working, it's great. But then a month later, you come back and the R Markdown file doesn't work. It's like, what happened? Well, you only created you only loaded the library in your session, not in the file you have to, copy paste it into a chunk. So this will catch those sorts of errors immediately while the analysis is fresh in your mind, so they're easy to fix, as opposed to months later, or someone else who didn't do the analysis trying to figure out why is this not working, it's because of missing library. On the way this works is with the call R package, which I have a link to there. Okay, versioned. So I really love version control. It's great for keeping a track of your what you've done and the decisions you've made. It also helps you move forward. You don't have to keep saving each working copy of your script and keep calling it _1, _2, _3. You can continually update the script or in the R Markdown files, knowing you can always get back and see why you made these decisions. But version control, it takes some time to get used to. I remember when I learned it, it was tough. I had to wrap my mind around it. So it's really tough to ask someone who really wants to get into the data analysis, oh, first, can you learn how to use Git before you do anything? Most people want to get into the analysis right away, understandably. So what Workflowr Io does is it tries to automate a lot of the Git part, so you can focus on your analysis, but you still get the log and all the benefits of version control without first having to spend months learning it. You can kind of learn it as you go. And so for this, we already talked about workflow build. That is for viewing the website locally on your own machine. When you're ready to share it with other people, what you're going to do is you're going to publish it. And that's Workflowr Io's basically terminology for version controlling the R Markdown file, rebuilding the HTML, and then versioning the HTML. So it's a 3-step process. First, it commits the changes to the source R Markdown file. Then it's going to rebuild that HTML. It actually inserts information about the R Markdown Git version into the HTML. So if you're looking at any HTML page on a Workflowr created website, you know the exact version of the code that created it. And lastly, we talked about how Workflowr commits actually the changes to the HTML files and all the plots that were created, so that not only is the source code versioned, but you have a version of all the results. And you don't have to use Workflow Publish if you want to do these 3 steps yourself. But there's a check, and one of the checks will make sure you did it correctly, because it's very easy to say, you try and commit them both at the same time. You don't actually know if you made it. It's very easy to make a mistake where you create the HTML, go back and edit the R Markdown, forget to rebuild the HTML, and then commit them both at the same time. And then you'll think that the HTML was actually created from the R Markdown, but actually wasn't. It was from a slightly different version. So this sort of protects you from ever making those sorts of mistakes. And that seems a little subtle, then don't worry about it. This basically protects you from that. I'm not going to get into this. This is more for the people who are already familiar with Git to understand how Workflowr is working in the back end. So if you're not familiar with Git, that's okay. You don't have to understand all this right away. But the idea is that there's a workflow status function, and it's combines the Git status of the R Markdown file with the Git status of the HTML file. And the big thing is that HTML file, is it the latest version, from the latest version of R Markdown, and they're both version controlled. Okay, and so shareable. So you've got this great version controlled website. You want to show it to people. So how to get it online. So both GitHub and GitLab have free services. There's GitHub pages and then GitLab pages. And it's really nice because it's tied directly to your repository, and it's free for public repositories. So you'll get you're already using GitHub or GitLab to store your code. You'll immediately get a nice website. And this way you can send a URL to your collaborators or put a URL in your report or research academic article that people can come and look at the latest results. So Workflowr helps with this. You don't have to use Workflowr for any of this stuff if you're already familiar with GitHub, and GitLab or GitLab. But it provides functions for a one-time initial setup. We give it your username, helps create everything, get it ready. And then whenever you have new changes you've made, you can do Workflow Git push. This pushes up the changes to GitHub or GitLab. And there's nothing special particularly about this function other than it runs in R, so it's convenient for those that want to stay in R. If you're already familiar with Git, or if you like the RStudio Git pane, you can push however you want. You don't have to use this function. Okay, so one of the coolest features is my favorite ones is this table of past versions. So this is where I was talking about how you're getting the benefits of using version control without having to become an expert first. So let's say hypothetically, one of your collaborators says, oh, I want to see that. Can I have a copy of that version of the figure you used in a presentation 6 months ago? So normally you'd have to go into Git, you'd have to check out the old version, you'd have to do some fairly complicated Git procedures yourself to find that. But with using this way, basically your collaborator doesn't even have to ask you for that. They can go to the table past versions, look at the date, and click on it. If they click on the HTML, it renders a version of the HTML exactly how it was, how it appeared back then 6 months ago. And if they click on the R Markdown, I'll take it to GitHub or GitLab, the exact version of the R Markdown that created it. I just know that the HTML is actually done by the service called githack.com. So I didn't create that. That's a nice free service. That's really great. And I'm showing that the example here is created by my collaborator, Peter Carbonetto. Okay, and so that's how Workflowr helps you stay organized, reproducible, version, and shareable. You create these websites. You can try it out for yourself. It's on CRAN, so getting to installing it is straightforward. You do install.packages Workflowr, and you automatically have it. You will need a account on GitHub or GitLab if you want to be able to share more widely. You get plenty of benefits if you just want to use it on your own local machine. It helps you keep everything organized and versioned for yourself. But obviously, a lot of the features some of the features I showed do require it to be public. And if you want to get a quick sense of whether or not you would like this for one of your projects, I have a getting started guide. It takes you from installing the package to having a small little toy website that you have hosted on GitHub that you can try out and see if you like it. So some limitations: Workflowr doesn't try to do everything for you. It really tries to focus on automating reproducibility checks and version control. So it records the software dependencies. I talked about how it does that, runs our session info at the bottom of each of your files, but it doesn't do anything to actually actively manage them. And the reason is I don't want to be prescriptive. There's so many different ways you can do this. You could use RM, you could use Conda, you could use Nix, you could run the whole thing in a Docker or Singularity container. It's up to you how you want to do it. And then whatever you do choose to use, the session info will always record that. So if you need to look and say, oh, did I run this? Which version of the Docker container did I run this in? You can look at your session info and immediately know. Another thing is this is trying to capture that data analysis step where you're trying different models, you're looking at the data, you're trying to understand the relationships, you're plotting things. So it's sort of trying to formalize and version this interactive process. If you have some complex steps where you have like 100 steps, you need to process thousands of files, Workflowr is not meant really to handle that. Then you want to use a pipeline tool. For example, targets is a common one, so it's also an R package. And there's issue 238 here. If you click on that, there's Workflowr users discussing how they incorporate and use both targets and Workflowr to make their projects more reproducible. Okay, and so a newer thing, so Workflowr has been around for years now. A more recent project is Workflowr Io. So I said I want to help share these projects. But right now, before Workflowr Io, the only real way for someone to find out about it is either you email them directly, say they're your collaborator, you put it in a report or academic paper and they read it there, or maybe you have it on your GitHub page or your personal website and someone happens to come across it, right? So it's not these things aren't very discoverable. So what Workflowr Io is, it is a central curation website that shows projects that have been created with Workflowr. So it makes it easier to find it. Other reproducible projects. And so a quick little screencast here. If you go to projects, here's a nice big list of projects with the different tags about what they're about. And you can click on those to be taken to a page. And also publications are supported here. So if you use Workflowr for your research and then you create any sort of publication that generated DOI, you can also include that and it'll be included on Workflowr Io. So you'll be able to show both that you're basically it's a way to advertise that you're doing reproducible research and other people interested in reproducible research can find it. And just here's a quick example with a screencast. So this is my former colleague at UChicago, Brianna Middleman. She did her PhD project using Workflowr. And so you can see here on the website, it has a link to her GitHub repo, as well as the paper. You can go straight to the journal article that was produced by this. And getting your project on, if you're interested in this, it's just a few clicks. It's done via GitHub app, so you install it on the repositories you want to share. So if there's only one Workflowr project you want to share, you just install it on that particular one. If you want to have tags on the website, these are just the topics from the GitHub repository. So if you're familiar with that, it helps you both with GitHub and Workflowr Io for people to find your projects. And if you want to have a publication on there, you open an issue and provide the DOI of the publication, and I'll get it on the website. All right, so acknowledgements. So my Workflowr users, the contributors, and also the wider R developer community. Like I said, I've extended and taken advantage of a lot of very useful open source R packages that Workflowr would not be possible without those. And then my former PI, Matthew Stevens, he's the one who funded all the work. And then my close collaborator, Peter Carbonetto, helped with everything. This was funded by the Gordon Betty Moore Foundation, a grant to Matthew Stevens to support reproducible data science. So I'll pause there because we're going to, switch into OmicNavigator will be a big transition. So if anyone has a burning question now, happy to take questions now. So I'll just wait a second here. All right. Okay. Then I will move on. Feel free to ask Workflowr related questions later in the talk as well. Okay, so the next one is a gear. Let's try to change of gear. So Workflowr is great for any field, any data analysis project. If you're using R and you like R Markdown, Workflowr will work great for you. This next one is more biology and genomics focused, but that's sort of the details. The overall strategy of creating a web application, I think, is very widely applicable. Like I said, the main theme is here is if you have generate some cool analysis, setting an Excel file or a PowerPoint is a very static way for your collaborators to interact with your results, right? So if you can create an interactive web application, you can send them that URL, always push the latest updates and data to it, and they can play around and get a much better sense of your results. And so that's what I'll tell you about today. The next part is about organizing, sharing, exploring the results of genomics experiments. Let's check the time here. Okay. So a quick line on this section. So let's talk about some of the challenges we were facing doing collaborative cross-discipline drug development. I'll talk a lot about the Opencpd framework, which is the big framework we used for this project. I'll go a little bit over about the background on the data, since not everyone's going to be a biologist. And I'll go into our specific solution of OmicNavigator, and also have a quick little comparison to other R web frameworks if you're curious about what would work well for you and your team. Okay, so first the challenges. So this I developed with colleagues at AbbVie. It's a pharmaceutical company north of Chicago in the US. And so in early stage discovery-based research, there's lots of collaboration. So there's a therapeutic area scientist. So they are responsible for running the experiments, interpreting, and deciding what to do next. They collaborate with computational biologists who use their expertise in statistical programming to analyze large data sets and use best practices. And what often happens, because after the computational biologist finishes the analysis of data, there's still a lot of work to be done. There's still interpretation and a lot to be done to try and understand what were the results. And what happens a lot of times is ends up getting emailed back and forth. Oh, can you apply this filter? Here are the results. So this slows down the TA scientists. They want to be able to quickly explore and ask questions and think about what is the next experiment I'm going to run. And the computational biologist wants to be working on the next statistical analysis instead of, say, creating an extra graph or creating another filter, things like that. So at AbbVie and other large pharma organizations, there are a lot of web developers that are tasked with creating software to help the drug development process. So we decided to use their expertise to try and create a web application such that the computational biologist can then upload the results once, and then the TA scientists, they can perform queries and subsets and quickly get feedback without having to wait for the computational biologist to answer their questions. And this allows the computational biologist then work on the next project. And like I said earlier, this was all created in the context of drug development, and all the examples that OmicNavigator works with are very much biology focused. But the overall idea and strategy should feel very familiar to all disciplines, right? Where there's a data scientist that is very familiar with the data and the analysis, but then they need to communicate with domain specialists that have to make decisions based on the results of these analyses. So this is a really nice paradigm of creating web applications that allows them to explore the data better. And so that's what was our main motivation to creating OmicNavigator, which is a web application for exploring these genomic experiments. Right, and so the front end, the website was created all with the JavaScript and was collaborated with JavaScript developers, but we didn't have to reinvent the wheel and find out some way for R and JavaScript to communicate. We used a very versatile Opencpd framework. So first, a little bit of web development basics, since I'll be using this terminology. So the front end versus the back end. The front end refers to the code running in your web browser. So on your computer, when you're clicking around on there, that is JavaScript code. If you say, click on a thing in a table or click on a plot, that's all JavaScript. R can't run in the browser. The back end is another server somewhere else. This could be on a cloud server or just anyone's server in their basement. This is the back end. So this code is only running there. It can't run in the browser, right? So R could run here or really any other programming language, but it's not as quick or interactive. And so what Opencpd is going to let us do is connect with R code running in the back end with the interactive front end. And it does this by taking all the R packages installed on the server and converting them into an HTTP API. And that's HTTP is the communication layer of the internet, or the main one. And so that's how we did it. And so an example of how this works. And so it automatically makes it really nice because it will convert back specifically to JSON, but also to other formats. Using the JSON Lights package is also developed by Jeroen Ooms, the developer of Opencpd. So what I'm showing here in this clip on the left, so the JSON Light package, I'm taking the first row of the empty cars data set. It's a built-in R data set. I'm converting it to JSON. So this is code that then JavaScript developers could consume in their code in the application. But they can also send data back to R. So if you go from JSON and you pass this back, it'll turn it into a one-row data frame. So this whole communication layer is completely solved by tools like Opencpd and JSON Light that you can develop. As an R user can collaborate with JavaScript developers without a lot of headaches. So here's an example. So because Opencpd exposes it as an HTTP API, you can query that using however you want, right? You could do it via JavaScript, but you could do it via another programming language, say Python, or here I'm just using the curl command directly in the terminal. So Jeroen, the Opencpd developer, has a public cloud where it runs Opencpd. So you can see here in this long URL, I'm going to this public cloud. And the way Opencpd works is it takes everything in your library directory. So this is, if you look after the OCPU / then it says library base r.version. So that's basically the path to that R function on that server. And then I specify JSON because that's the output I want. And so if I call this r.version function via curl, I get back this result in JSON. So it's as if I ran this locally. I get all this information about the R running on this public server. And so at the time I made this slide, it was R version 4.1.2 that they were running. And so what this means is that the full statistical power of R is now available to your web applications or really any other application. So here's an example. I'm calling the public cloud where I'm saying, okay, I want a Poisson, give me 3 random Poisson values with a distribution with a lambda of 3. And so I get that back as JSON. Then I could say, okay, I want the max of these 5 numbers, this vector of numbers, and I get back the max. So these are just trivial examples to show you that they can fit on one line here, but you can install whatever R packages you want on your server running Opencpd. So if you have some complex machine learning algorithms, you want to do some prediction in that web application, you can call out to a very sophisticated prediction algorithm and get the result back from R directly in your application. All right, so that's a lot about Opencpd. So what about the data we're going to be doing? So this is a quick sort of primer to give you an idea of the data. Let's check my time here. Okay. So what's an omic? So it really refers to any high throughput measurement of thousands of molecules per sample. So you may have heard of some of these, even if you're not a biologist, but so genomics, that refers to measuring or sequencing or collecting the genes in a genome of an organism. Transcriptomics is when the experiment measures the RNA transcripts that were created from those genes in a sample. Proteomics is measuring all the proteins. And then metabolomics is measuring the metabolites levels basically created by their enzymatic reactions in the sample. And so what's a typical omic experiment look like? So the experiment measures thousands of molecular features in every sample from multiple different treatments. So you can imagine like a control versus multiple different types of treatments. And then statistical test is using a specialized type of t-test, doing all the pairwise comparisons between these groups to find the features that have changed between your groups. That's statistically different. Okay, and so a typical way of displaying this, and I'm using this because it's a screenshot direct from our app. It is prominently displayed in our app. So it's called a volcano plot because it looks like it's exploding. On the x-axis is the log fold change of that feature between the two groups. So this is a measure of the effect size and the direction. And on the y-axis is a statistical significance. It's the negative log of the p-value. So the lower the p-value, the higher it is on this plot. So your most significant, statistically significant and large effect size features are going to be at the tops, the two tops of the volcano. Okay, the last little detail about these, how these experiments are typically laid out, that'll help explain the layout of and design of our app. And I talked about how there's multiple groups, say like a control group and then multiple different treatments. So say in a model experiment with 3 groups, your model might have, statistical model might model all of them at the same time, but then the different contrasts or tests you do, you're going to do them each pairwise separately. So if you have 3 groups, you have group 1 versus 2, you have different results for group 2 versus group 3. And then lastly, group 1 versus group 3. And so basically when you input the data for OmicNavigator and also when it's displayed, this has this thing where you choose a model and a test, and that's where this comes from. Okay, so more about our solution, OmicNavigator. Okay, so I'm going to go so there's lots of moving parts. So the way I'm going to go through is sort of the typical sort of life cycle or workflow of how you would use the app. So remember that the TA scientists have performed the experiment and the computational biologists have performed the statistical analysis. So they could do it however they want. They can use R, they could use a different programming language, they could use a GUI, a point and click solution, however they want. OmicNavigator is agnostic to how the analysis is done. It assumes that the computational biologist is the expert and has chosen the appropriate models to do. So once they're done with the analysis, now the time is to prepare it for ingestion by OmicNavigator. So this is also on CRAN. So install packages, OmicNavigator will get you the package locally, you load it, and then to get the JavaScript application, we provide a function called install app. You only have to run that once, you'll download the version, the latest version of the app. Okay, so to give you an idea of what this looks like, I'm going to show you a very, very minimal study. So calling it quick start. And all these instructions are on our README. We also have extensive, I think I linked to it later, an extensive user's guide that will walk you through this as well if you're interested. So I'm creating a study called quick start using the function create study. I'm going to load, so I load this data called RNA-seq123. This is a nice, I don't know if I have I think I have the citation later. But anyways, this is a subset of a published data set that we packaged with the study, with the package for demonstration purposes. So what I'm doing here is I have this results table where I have the first column, it says entree ID. This is sort of the unique ID of each feature in the experiment. And then each column is a result from the statistical analysis. And the way I add this results table to my quick start study object is using a function called add results. And what it takes is the existing study object and then a nested list. So this gives you lots of flexibility. If you have multiple models or multiple tests, you would list them all here. In this simple example, there's one model, one test. So it can all fit in one line. So this is the most minimal. There's lots of extra things you can add, but the minimal thing you can have is one results table. So if you then install this study, that will convert into an R package and install it on your system. Then you can run start app, which will run a local instance of OpenCPU on your local machine only so that you can preview it. And so to give you a sense, there's a lot of moving parts here. So the OmicNavigator web app will be started by start app. And so when you click around and they ask for more data, what will happen is this will make a call to the OmicNavigator R package via the OpenCPU facilitated HTTP API. And then that package will then, the R package function will then go and look for the study packages, specifically the quick start one here, and load the data from that. So here's a screenshot of what this very minimal study will look like. On the left here, I've chosen the model and the test. In this example, there's only one of each, so that's not interesting. But if there were multiple, you'd be able to choose them. Here's that results table. It's exactly what we saw in R, but now if you send this to somebody, they can be able to sort and filter and search this table dynamically. And it's also linked to this volcano plot up here. Anything selected in the table or in the plot will then update each other. So if you subset the plot, it will subset the table and vice versa. And you don't have to be limited to this volcano plot. You can actually give it any of the columns from the results table with numeric values. You can make it you can have be the axes of the plot. So like I said, this was the most minimal study possible that's supported. So as you add more stuff, each thing you add will add new features in the app. So you can add metadata about to describe the features. Those will be included in the table. You can add enrichment results. It's a whole nother pane. You can add plots. So if you have plots, custom plots you want to create per feature, you can write these and add them to the function, to the package, and they'll be rerun automatically. And also if you have link outs to external resources pages, like a database or something, you can add those directly to the table as well. Okay, so how would it look like to share with this? So you have a couple options. So if you export the study, it'll create an R package tarball. So then you could either install it on a server you manage. So if you have like say Amazon or Google Cloud, you can copy it there and install it. And then you send them the URL wherever it's running, or you could share the tarball with them directly, and then they can install it locally with install.packages and run start app. Okay. So that study that I showed you first was just starting off simple. So we also provide an example one and another repository. These are the directions to install it. So if you want to see what the app looks like when you actually include many features, we have this whole study. So you download the tarball, install it, and then you run start app, and you'll be able to see it. And then here are the references for the studies where we've taken this data from. Okay, so I'm going to start you some screencasts, but first to orient yourself. So now you can see on the table, it's a lot more interesting, right? So these link outs and also feature metadata, so the symbol and the chromosome. So those are extra data about the features. Oh, that's okay. So we're going to the screencast. So I click on a top feature in the volcano plot, and immediately highlights in the table, and then it's showing me all the custom plots that were created. Then I can subset the volcano plot, which will then immediately subset the table, and then I can make a custom plot on top right here for multiple features at once. Okay. So another thing that's really nice, and this is something that's a common use case where like, oh, they want to be able, the TA scientist wants to be able to filter by different parts of test in the experiment. This is a little bit harder to do. It's kind of, it would be awkward to do with an Excel spreadsheet, right? You can filter just one easily, but trying to filter based on multiple different Excel sheets would get really cumbersome. So we have this analysis, set analysis tab, where what I've set here is it needs to be statistically significant with a p-value less than 0.05 for the first and third test, but not the second. And so what you're going to see here is this is what I'm going to do. I'm going to do that. So I open the set analysis table. I have the p-value. I make my settings. I click filter. So that automatically updates the volcano plot and the table. I click on an example to check, and you can see here that it is different only in that second group as I expected. Okay, but wait, there's more. So I don't have time to go back and go into the sort of motivation for each of these features. So this is more for any biologists listening. So we support upset plots. This directly uses the CRAN package upset R. We have an entire pane for the enrichment networks for enrichment analyses, and this is inspired by the enrichment map Cytoscape app. And we also have interactive barcode plots to really drill down to when you have an enriched term from your enrichment analysis, you can interactively look at what features are driving that enrichment. And this is inspired by the lemma function barcode plot. Okay, so a summary of the OmicNavigator steps. The bioinformatician or computational biologist performs statistical analysis using their best practices. Then they install the OmicNavigator package. They create a study package that contains the results, and they export a study tarball. And then that bioinformatician either shares the study tarball directly with the collaborators for them to run locally, or it installs it on the server to send them the URL. And then the collaborators can quickly explore results and generate hypotheses and ideas using the web app directly. And they only need to contact the developer, the computational biologist, if they have something, a custom analysis they need done. Okay, so I'll speed through. I see we're about at the hour, so let's speed through a little bit at the end of this. So why did we, we didn't really need to store the study results as an R package. That was a choice we made. And the main, we could have done, say, a database or flat files and directories. So the reason we did that, the big motivation is those custom plots you saw. Those are actually R functions embedded into the, included in the study R package. So if there's a plot and its dependency, say it depends on ggplot2, like this example here, that is included as a dependency. So it just makes it a lot easier to include code that can then be run by OpenCPU. But because we chose this, we can take advantage of the versioning of a study package. So you can imagine if you get new data or you update how the analysis was done, you want to increase the version of the study package. And we've also talked about distribution. How do we share these results with other people, our collaborators? Having the R package structure makes it easy to create, and then you can have the one file to give to somebody else, and then they can install it with install.that packages. So we have to invent any new infrastructure for that. Okay, so we chose OpenCPU, which worked really well for us. So compared to some other web frameworks, so why would you choose OpenCPU like we did? So if your team is multilingual, if you have R developers and JavaScript developers, and you want them to be able to use their expertise and their domains without having to have them all try and install each other's tools, OpenCPU is great. If you know the R functions will be used directly in R as well from the app. So remember, in our use case, the bioinformatician adds the data in R interactively, but those same functions are then called by the app via OpenCPU. So what's nice is because OpenCPU automatically creates this HTTPI from existing R functions, you get both. If you're already comfortable with writing R packages, it's really nice because then all the documentation and tests and that sort of thing, you get to use all that infrastructure when you're developing your software. Lastly, one limitation, you have to be okay with an out-of-the-box setup for your web server. So remember how I showed you those paths to the exact of the R functions, right? If you wanted to make it have a be more fine-grained and say like, okay, I want my API endpoint to be /predict or /model or whatever, you really can't do that with OpenCPU, at least not easily. You have to use the directory structures like library name of your package, name of your function. So why would you choose an alternative then? So if your team is mainly R developers and not web developers, Shiny is a great option because you define both the backend server code as well as the front-end user interface, all in R. If you need that fine-grained control of the API endpoints, like I said, if you want to have your API endpoint be /predict, or if you're going to parse some of the HTTP headers, or if you really want to have a new format, Plumber would be a great option. If you want to create a more traditional MVC web server, sort of like something you'd create with the Python package Django or Express.js, but you want to stay in R, I think the Ambiorix package is pretty cool, and it'll allow you to create an app like that. But these are only a, sorry, there's a link at the top. This is only a very small subset. There's lots of options. You can go to the CRAN task view on web technologies. It has a list of all the available web and server frameworks, so you can find out what would work best for you. So in conclusion, OmicNavigator facilitates collaborative analysis, exploration of high throughput Ohmic experiments, and more generically, OpenCPU enables R and JavaScript developers to combine their expertise to create data-driven web applications. Acknowledgements. So Brett Engelman is my manager at AbbVie. He is the sort of the brainchild of this and helps direct it and manage the entire project. AbbVie Incorporated for the support and helping out, letting us open source this. And then my AbbVie colleagues who did all the JavaScript development. And lastly, you're in OOMS for the very nice OpenCPU framework. So like I said, if you want to learn more, so the README has the quick start guide. That's some of the code I went through. If you want to go more in depth, we have a user's guide that you can go through. It's a vignette. You can take a look at the example. And then also you can look more about OpenCPU in general at opencpu.org. Real quick attributions from the icons from the noun project I used. So thanks for listening, and I'd be happy to take any questions. I'm gonna stop sharing.
Okay. John, I want to ask you a question.
Okay, go ahead, Samuel.
So how with OmicNavigator built on R and JavaScript, does it work on R Shiny? If not, how is it related with R Shiny?
How is it related to R Shiny? I would say they're trying to accomplish the same thing, but they're different strategies, right? So Shiny is purely for the R developer. They allow them to write, if you've done some Shiny development, you have your server functions and your UI functions.
Yeah.
So basically, if you're using Shiny, you can use those UI functions, but you're dependent on other R developers having created those packages for you to use, right? So if you want to use some new JavaScript functionality, some new JavaScript thing, you have to wait till an R developer creates the package that wraps that for you. Because what a lot of those user interface functions are doing is you write it in R and then it converts it to JavaScript when you build your Shiny application, right? Okay. So that's really useful if your team is only R developers, and that's the only option you have. But if you have a question, say from one of your JavaScript developers you work with, they don't know Shiny. They won't be able to help you debug it, for example. So to me, that's the big difference. You're still creating a web application. The question is, do you want to write the front end and the back end in R, or do you want to run the back end in R and the front end in JavaScript? So that's sort of the decision, right?
Okay.
Hopefully that helps clear it up a little bit. There's a lot of terminology involved in web applications, and so if you're mainly in statistics and you haven't had a lot of experience with this, it can take a second to learn all the different moving parts, for sure.
Yes. Okay. And is it possible we go back to the slide where you talk about the molecules and the other stuff? I want to ask a question there. Hello?
Can you ask your question, Samuel?
Yes. So if someone is working on single nucleotide polymorphism, I don't know if you are a biologist or something.
Yeah.
Single nucleotide polymorphisms. Mm-hmm. And then you've taken your data, you've run your samples. Is it possible you do your data analysis using the Ohmic?
I see. To explore your results with the OmicNavigator?
Yes.
I'll say yes and no. So you could, if you subset your data. So when you have single nucleotide polymorphism or SNP level data, that can be millions and millions of rows of data. And whereas we designed OmicNavigator to work more in like the tens of thousands of rows of data. So it would probably be too slow. But if you subset your data to interesting regions, so let's say you did something like fine mapping or some sort of post analysis where you subset to specific regions of the genome, where you only had, say, 10,000 SNPs in that region, then you could do that. Like you could have each one be a test or something like that. So if you had a bunch of different regions of interest across the genome, and you split them up into different tests, and then each one was a different test and different test table, results table, then it would work well with OmicNavigator. So sort of how does it just, it depends on how you are organizing the results and in the questions you have.
Okay, thank you.
All right, thanks for the questions. Anybody else?
So concerning the workflow session, okay. Workflow got to do more with reproducibility. I think it's very important as statisticians or people dealing with data to get to know some of these things. You know, there are a lot of errors and fraud in statistics now. And if people are able to have this kind of presentation with Workflowr Io, you know, you'll get to know exactly the kind of packages the person used. And when you spoke about seeding your data, using the seed, whenever anybody runs the test, the person should be able to get exactly the same result. And that is where we are getting to, where whatever research you do, somebody sitting elsewhere should be able to take the data and run and get the same result. So I believe it's a very useful package that we must all get to know and study more about, and it's going to help all of us. So I believe we are going to make very good use of this presentation. Thank you. Just a little add up to it.
I appreciate that. And yes, that's exactly the motivation of Workflowr Io. Yep, let's make things more reproducible. So I hope you find it useful, and feel free to open issues if you have any trouble.
Yeah. Please, any more questions? I think we have like 5 minutes. Yes, we have 5 minutes to end this presentation. Okay. And as we wait for people to ask questions, John, you were talking about your R user group having some workshops. And I wish if that comes on, you can invite some of us to join and also learn from there.
Yeah, so definitely. So I can send a link in here in a second, but so I'm a co-organizer of the Cleveland R user group. And so we meet usually once a month. It's at 6 p.m. our time, which will be 11 p.m. your time, which will be a little late. But we typically have presentations like the one I just gave, where someone will share about, either a package they developed or an analysis they did, and just sort of share it with the group. And then we ask questions. Yeah, let me, while we wait, I will set a link there, because you can join on meetup.com, and then you'll get all my emails and notifications about. Okay, so I just put the link in the chat. But yes, if you want to join us, the Cleveland R user group, if you go to meetup.com and join, whenever I create a new event, you will see it. And because of the pandemic, you will be able to join for the foreseeable future, because we're doing virtual. So you are more than welcome to join us.
Thank you.
Great.
Okay. So.
And on the subject of the user group, congratulations on your 3-year anniversary. It was an honor for me to be here to talk with you, and that's great. Great momentum. I know as a user group organizer how much work it is to sustain a community. So keep up the good work.
Thank you. Thank you. So, Mr. Francis, are you around?
Yeah, I'm around. I'm just kind of well, I'm around. So I was just listening to John's presentations, And then I think just regarding workflow, I think when I was studying computer science, our lecturers were taking us through this workflow thing, and I actually didn't take it serious. But as John was just presenting, as he was just showing us charts and things workflow does, I think I'll probably exploit on the user guideline to probably get more insight about it. So I just want to thank Prof. John for his time and for the honor he has given to us by accepting our invitation. Maybe within some time, we think of organizing one conference with him, just one-on-one, for him to take us through more on it. Yeah, so I think this is just a small thing I just want to say. And I want to thank everyone for joining us with this our conference. And I want to just say God bless you. So I think over to you, Samuel. Yeah.
Okay. Thank you, Francis. John, once again, we want to say a very big thank you to you for your time, your effort. And we believe we are going to have wonderful time in the future together. This is the first and not the last. And I believe we are going to build a better relationship in the R community, both in the US and in Ghana. So thank you once
Great.
again.
Yes.
And we are
Thank
so
you. It was a
much
pleasure.
grateful. Thank you. We are going to end the meeting now. All right.
Yeah.
So we continue our sessions tomorrow. And God bless you all for coming today. And you'll meet on our WhatsApp page to continue from there. Thank you.
Thank you.